Welcome, this is Radiant, and today we're tackling a new paper from MIT that is, frankly, mind-bending. It could completely change how we think about AI learning. We're talking about moving past AI that just knows a bunch of stuff and into the territory of an AI that can actually learn, all by itself.
So, let's just kick things off with a big question. What's the one single thing that you can do that even the most powerful AI today, like a GPT-4, just can't? And I'm not talking about creativity or having emotions. It's something way more fundamental to how we operate in the world.
And that difference? Well, it brings us to what you could call AI's glass ceiling. It's this invisible barrier that means even the smartest models are basically frozen in time. They're brilliant, for sure, but their brilliance has an expiration date.
Right, so here's the core of the problem. Today's big AI models, these large language models, they're static. See, they learn by forming millions of connections, called weights, during this huge training process. But once that training is done, those weights are locked in. It's like a genius professor who graduated in 2023 and was the smartest person in the world, but can never ever read a new book or article published after that. To learn anything new, you'd have to put them through college all over again, a massive, eye-wateringly expensive process.
And this really shows you the split screen between us and them. On the left, that's you. That's me. We're learning all the time. Every single day you read something, you have a conversation, and you subtly update your model of the world. Our knowledge is alive, it's dynamic. But on the right, that's current AI. It gets one giant all-or-nothing cram session, and that's it. From then on, it's just playing back what it already knows. It can't really grow.
So, the billion-dollar question is, how do you break that glass ceiling? Well, this is where that new MIT paper just blows the doors wide open. It asks a pretty radical question. What if we could build an AI that learns the same way we do? What if an AI could study?
The researchers used a super simple analogy, which I love. Just think back to how you'd study for a big test in school. You wouldn't just stare at the textbook for hours, rereading the same chapter 100 times, right? You just know that's not how learning actually works. Nope. You get active. You grab a highlighter, you take notes, you try to explain the ideas in your own words. You're basically wrestling with the information, restructuring it, and reformatting it until it clicks in your own brain. You're making the knowledge yours.
And that right there is the big idea. The MIT team took this very human concept of active learning and asked a game-changing question. Can a large language model learn to do this for itself? Can we teach an AI how to take its own study notes?
And their answer is a framework they call SEAL. It stands for Self-Adapting Language Models, and it does exactly what it says on the tin. This is an AI designed to keep learning, to adapt and evolve after its main training is over. It does it by generating its own study guides and then using them to permanently update its own brain.
Okay, so how in the world does this actually work? How do you teach a machine to be a good student? Well, it's not magic. It's actually this really ingenious self-improvement loop where the AI gets better and better at learning over time.
This whole process is laid out right here. Let's walk through it. First, the AI reads some new info and writes its own notes on it. They call these self-edits. Step 2, it uses those notes to make a quick little tweak to its internal wiring. Then, step 3, and this is the crucial part. It gives itself a pop quiz. It tests itself on what it just tried to learn. Step 4, if it gets the answer right, the study method it used gets a reward. If it gets it wrong, no reward. And finally, step 5. Over thousands and thousands of these cycles, the AI uses those rewards to figure out what good study notes look like. It's not just learning facts anymore. It is literally learning how to learn.
You can think of it like the AI is running little experiments on itself. It's constantly trying different study techniques. Should I summarize this or should I turn it into a Q&A? The reward system tells it which strategies actually work, so it becomes a smarter, more efficient learner with every new fact it encounters.
Okay, so the theory is really, really cool. But does it actually work in practice? This is where things get wild, because the results from letting this AI teach itself are, to be honest, pretty stunning. So get this, the researchers took their model, which is way smaller than something like GPT-4, and they had it go through this whole learning-to-learn process. And what they found was that their little model became better at writing study notes for itself than the giant state-of-the-art GPT 4.1 was. The student didn't just become the master, it became a better teacher for itself than the master ever was. And here's the headline number. After teaching itself how to learn, the SEAL model could correctly answer questions about brand new information almost half the time, 47% accuracy.
Now you might be thinking, hey, 47% is a failing grade, but hold that thought because you have to see where it started.
This chart really puts it all into perspective. Let's look at that first bar on the left. The original model, before any new learning, scores just under 33%. Okay, now, in the middle, you see what happens when you give it study notes written by the super powerful GPT 4.1. Accuracy shoots up. It hits 46.3%. That's a huge improvement. But then, look at the bar on the right. That seal, using the notes it taught itself to write. It actually does even better. Think about that. It learned how to learn so effectively that it got more out of its own notes than it did from a much bigger, more advanced AI.
So let's zoom out. Why are we so excited about one research paper? Because this isn't just a small step forward. This could be a monumental shift in what artificial intelligence even is, from a static tool to a dynamic, evolving intelligence. So, what does the future with this tech look like? Well, for one, it might solve the data wall. The fact that we're literally running out of human text on the internet to train these things on. An AI that learns can create its own high-quality data. It also means AI stops being just a tool we use and starts becoming a partner that learns and grows with us. And finally, this is the building block for truly agentic AI. Systems that can go out, interact with the world, and learn from those interactions, getting smarter every single day.
Just try to picture this for a second. An AI that can read a brand new scientific discovery, and not just give you a summary. I mean an AI that can truly internalize it, update its fundamental understanding of chemistry or physics, and then use that new knowledge to help solve the next big problem. That's not a static program. That's a system that grows. It evolves.
And that brings us to the final, and honestly, the most profound question. If a system can learn from its own experience, if it can continuously adapt its own internal structure and evolve its understanding of the world all on its own, what does it become? It starts to look less and less like a computer program and more like a kind of computational life form. So the big idea here isn't just that GPT-6 or GPT-7 will be smarter. It's that it might be, in a very real computational sense, alive. And that is a future that is going to be incredibly interesting. That's our breakdown for today.